This week is week 6. We will go over Module 6 lecture. Let's go to chapter 11 in the textbook. We will talk about inheritance. In chapter 11, you can see the chapter title called Inheritance and Polymorphism. Both inheritance and polymorphism are two important concepts for the Java object-oriented concept. So that's why we will break into 2 weeks to talk about that. This week, we will focus on the inheritance relationship. After you fully understand the inheritance relationship, then we will talk about the polymorphism. So this week, we will talk about the inheritance relationship. You will understand what is a superclass, what is the subclass. And we will talk about another keyword is the super keyword. In this week, after you have the inheritance relationship, all the constructor chain in the inheritance relationship, they will have the order. So that's what we will show you. And also we will go over the overreading and overloading. So that's the first few clips you need to watch before our lab exercise on Tuesday. After your lab exercise, then before you're moving forward to the assignment 6, please continue to watch 2 more clips. I will talk about the object class and the final keyword. So the first thing, let's talk about what is the inheritance relationship. So object-oriented programming allows you to define new classes from existing classes. That's what we call the inheritance. So on the other hand, that means you already have a class defined. Then we find out when we want to develop the new class, they have a lot of things duplicated. But also we have some new thing we want to cover from the new class. So then we find out instead of to have the duplicate code, we also find the existing class and the new class, they have a relationship. And that relationship actually is inheritance relationship. And inheritance relationship is a relationship. Did you see that's a little different? Last week, when we talked about composition, aggregation, we talked about has a relationship. But now, when we talk about inheritance, you need to think about those 2 classes. Actually, they used to model is a relationship. What does that mean? Actually, that means the new class you try to define, they are one kind of existing class. So on the other hand, that means the new class is a existing class type. So that's the important thing when we try to identify the class relationship. You need to know, are you implement a is a relationship or you are implement a has relationship. So they have 2 different implementation. They have 2 different approach how you implement that. So that's why inheritance relationship is only using for the is relationship. It is very important and powerful feature to reuse software. Because one thing is, if you have is relationship, actually we have some common component already defined in the existing class. So we kind of just want to reuse that in the new classes. For example, later we will introduce. You all understand circles, right? And last week when we start using the class example, we create a circle class. Of course, understand the circle class. You can create rectangle class. You can create triangle class. And don't you feel circle class, triangle class, they are all a shape, right? So that's why they have some very common feature. Like the circle, I can get the area. Triangle, I can get area. Rectangle, I can get area. So that get area actually can be defined in the geometry shape class. So with the inheritance relationship, actually they are a best way to design the classes to avoid a redundancy and make the system easy to comprehend and easy to maintain. But the most important thing, not all of them they can do that. All the inheritance relationship we need to base on, they have is a relationship. So in the Java terminology, when we talk about inheritance relationship, we call that the, for example, C2 extended from another class C1. So now you know the C1 is earlier, we say the existing class. Then C2 is the new class. In this way, we will say C2 extends C1. And also this new class, we call that a subclass. The existing class, we call that superclass. So sometimes you will hear in other object-oriented concept, we say the superclass, you can say that's a parent class or a base class. Then a subclass, you can say the child class or extended class, or derived class in C++. So no matter how we say that, they all have the inheritance relationship. All the child class inherits accessible data field and the method from its superclass. And also they may add new data field and the method. So like earlier we say, you see C1 is the existing class, right? The reason why C2 want to extend from the C1, that's because C1 have some field and the method C2 can be reused. So that's why those fields, we don't want to, those data field or method, we don't want to redefine the C2 with the same code. So instead, we're just using the C2 extends from C1. So that means C2 will have those attribute, accessible attribute or data field and the method from the C1. Then C2, if they have their own specific data field or method, yeah, we also can add a new data field and the method in the C2. Okay, so that's be careful. C1 is existing. C2 extended from that, but C2 can be added their own new data attribute or method. So here, that's our example. On this one, we see the circle class. Did you remember we have that before? Last week, we have circle class. So then you see here, we are in the UML diagram. So then we have the radius. We have some constructor function. We have some getter and setter function. So then here, let's create another shape class we call rectangle. Right, so then you will see very clear rectangle need to have the width and the height. So we either can have default constructor for the rectangle. We define the value for the width and height. Or you can pass me the new value. So then that's my constructor. So then you have the get width, get height, and get area, get parameter. You know, then later we find out, right, don't you feel circle and rectangle, they are one kind of geometry object? Right, so this geometry object, we just say, for example, the circle, rectangle we want to create, they are not only have their property, I also want to, when I draw them, I have different color. Okay, I want to have the shape to be filled or not. Or I want to have the date associated with the object. So those common attribute that's defined in our geometry object. That's our superclass. So then in order to demonstrate the inheritance relationship in the UML diagram, you see the object we're using the arrow. So the arrow you see here, we point to the superclass. So that means the child class is extended from the superclass. So the same thing here, you will see the circle and the rectangle inherited from the geometry object class. So now you see after I give you 3 classes UML diagram, you should be able to just write their Java class. So that's why I give you the demo code, but also here we just quickly go over the geometry object. So then here we have the private data attribute. So from now on, all your class definition, I need to have the modifier. All the data attribute define, I need to have the modifier. All the method you define, you need to have the modifier. So mostly we have the data attribute is private. So then the method and class, they are public. So we have the constructor function. So since here, you have two different ways. You have one way is the default value you put in the data attribute declaration, or you can assign in your default constructor. So here you can see the default constructor will only create the date. So then we find out user can give us a new value. So then you see here, we can pass the color and the Boolean field. So since those data attributes are the same as our host object, so that's why you see here when they assign the new value, we use the this keyword to distinguish the parameter variable color and the host object color variable. Okay, so then you have getter, get color, set color, get field, set field. So they created. So then again, so see here, remember last week we say, so from now on, when you have the get they created, please do not return the object reference. We need to make sure they won't be overwrite. So that's why we do the toString. So then here, that's briefly to talk about the toString method. The toString method actually for our class definition, we all using the toString method. The TO lowercase, then S uppercase. Then the toString method, the return type, please do not change. The return type are string. So this toString method we will talk about more later. But this toString method actually is the member method to display object information. So this toString method actually we already defined in the object class. So we know in Java, all the class, if all the object, if we call toString method, they give you a string to describe the object. So that's why you see here, we display the geometric object. We say when they created, what is the color and the field. So that's the toString method. Please make sure you don't change the method name. You don't change the return type. Later, we will talk about why you cannot change that. So now, after you define your parent class, right, or base class, so now you can see the geometric object will be a parent class to the circle class. So you can see here our subclass extends from the parent class. So the extends is the keyword to represent the inheritance relationship in Java. So then you can see here we have the radius is private. We have a default radius equal to 1 in the default constructor. Then we can update the radius, have the other with parameter constructor. So then you can see here, actually we even have more. Since our circle extends from the geometric object, right? So that's why circle class, circle object, not only you have radius, they can have color, they can have the field. So then when we have another constructor, we can pass in the radius, color, and the field. So then you see they update the data. You see here the radius we will assign to the this.radius. So the color we will call the setter function from the parent class to set up the color and the field. Then you have the get radius, set the radius, and get area. Okay, so then here we have another print circle information function. I quickly introduce everything, but you should download the file and read very carefully. So that's why rectangle I won't talk about more in detail because they are very similar to the circle. We also rectangle extend from geometric object. Then we have the length and the width private data. So then you should read the rest of that. They will be very similar about the constructor function and the getter statute.